binary covalent compounds are a little bit different than binary ionic compounds. They're made of two types of atoms that are bonded together, but they're bonded together covalently instead of ionically. So what we're going to see are atoms on the same side of the periodic table in these types of compounds. So binary covalent compounds are formed between two nonmetals. And remember that nonmetals are to the right of the staircase. We're not going to have a transfer of electrons where we've got one atom that's losing electrons and one atom that's gaining electrons to become stable. We're going to be looking at a sharing of electrons in order for atoms to be stable. When we name them, the first element is the full element name. But for the second element in a binary covalent compound, we're going to name it as if it's an anion. That means we're going to use the suffix IDE for the second element in a binary covalent compound. Now when we look at binary covalent compounds, we're going to need to designate how many of each type of atom we have in the compound. So we're going to use prefixes to denote how many of each type of atom are present. And one rule that we need to remember is that the prefix mono, which means one of a particular type of atom, is never used on a cation, or the first atom that's in a compound. But if we have one of the second atom in the compound, we will use the prefix mono. So let's go through the prefixes that are used in binary covalent compounds. Mono is the prefix for 1. Di is a prefix for 2. Tri is 3. Tetra is 4, kind of like the game Tetris you play on your cell phones has 4 little squares in it. Tetra is 4. Penta is the prefix for 5, like the pentagon has 5 sides. Hexa is 6. Hepta is 7. And octa is 8. Now there are other prefixes as well for binary covalent compounds, but we won't be looking at ones that are typically larger than 8. Let's practice with some binary covalent compounds. Let's say that we've got the compound PCl3 and we want to write the name of that compound. The first thing we should recognize is that phosphorus and chlorine are both on the right side of the periodic table. That means that they're binary covalent compounds, and we're going to use prefixes in their names. Now when we look at the compound, there is only 1 phosphorus and there are 3 chlorines. The prefix for 1 is mono, but we don't use that for the first element in a binary covalent compound. And tri is the prefix for 3, which we're going to use for our chlorine. So our name is going to be phosphorus trichloride. Let's say we've got NO2. Again, nitrogen and oxygen are both on the right side of the periodic table, so that's going to make it a binary covalent compound. We're going to use prefixes in the name. There's 1 nitrogen in the formula, but it's the first element in the compound, so we're not going to use the prefix mono. There are 2 oxygens, and our prefix for 2 is di. So NO2 would be nitrogen dioxide. Let's say we have CO. We have 1 carbon and 1 oxygen. We don't use the prefix mono for the first element in binary covalent compounds, but we would for the second. So here we have carbon monoxide. N2O5. There are 2 nitrogens and our prefix for 2 is di. There are 5 oxygens and our prefix for 5 is penta. So our name would be dinitrogen pentoxide. And we can put the A in the last name there just because it's a little bit awkward to say pentaoxide. We would just say pentoxide. So let's go the other way. Let's say we've got the name and we want to write the formula. So carbon dioxide. If you're looking at 2 nonmetals, which carbon and oxygen are both nonmetals, it's a binary covalent compound. And also, if you see prefixes, you know you're looking at a binary covalent compound. That means that the prefixes in front of the names for the elements designates how many of each type of atom you have. So in this case, if there's no prefix in front of carbon, it's assumed to be mono. The di in front of the oxide tells us that there are 2 oxygens. So our formula for carbon dioxide is CO2, 1 carbon, 2 oxygens. Sulfur hexafluoride. Again, there's no prefix in front of the sulfur, so it's assumed to be mono, so we're going to have 1 sulfur. There's a hexa in front of the fluoride. Hexa is the prefix for 6, so we're going to have 1 sulfur and 6 fluorides, and that's going to give us SF6. Disulfur tetroxide. So the prefix di in front of the sulfur tells us we have 2 sulfurs. The tetra in front of the oxide tells us we've got 4 oxygens. So our formula is going to be S2O4. Now for binary ionic compounds, we would simplify that 2 and 4. But for binary covalent compounds, we're going to keep the ratio the way it's spelled out in the name.